Hi, my name is Wenning Li. I'm going to present this Demixing project where we use graph neural networks to reconstruct the evolution of epidemics. Part of our motivation comes from the increased need to analyze the person-to-person spread of epidemics in high-risk communities such as nursing homes and schools. If we view the communities as a graph, residents can be the nodes and the edges can be interpreted as interpersonal contacts, and the epidemics will be signals spreading on this graph. In this sense, graph-based neural networks prove to better deal with graph signals than classical graph modeling and non-graph-aware learning methods. In real practice, we often face an inverse problem, where we're given only some temporally collapsed information, and the goal is to reconstruct the complete temporal spread. To that end, we propose the Demixing, which is a graph conditional variational autoencoder that can be trained from past epidemic spreads. During training, the posterior network learns to extract information from complete sequences Y, while the prior network learns to extract similarly distributed information from the collapsed signals X, which is to be used at test time. Then the deep projection network learns to reconstruct the entire epidemics from the latent space. In such way, this model will capture key aspects of the underlying spreading dynamics. To verify the efficacy of Demixing, we conduct experiments using both synthetic and real-world graphs. We adopt the SIRS model to simulate epidemics and show an example here where you can see that the contagion starts here and it evolves over time. On synthetic graphs of different density and different size, we verify that Demixing outperforms the CNN and MLP-based neural networks which do not exploit the network topology. Also, we show that with limited training data, Demixing converges easier than the others, which further indicates that it has successfully imposed the right implicit bias by incorporating the graph topology. With the real-world data, which is the context graph in the primary school, we find that Demixing recovery can accurately trace back to the source of epidemics over 20 days. In comparison, the non-graph learning methods tend to lose that track very quickly. In the future, we may verify Demixing on real epidemic processes, and we are interested in condensing information from the reconstruction or even without the full reconstruction. And we will accommodate for situations where we have only incomplete data or when we have missing data. Thank you.